exercise 11.1 from areas related to circles. So in the first question, they've given that we need to find the area of a sector of a circle with radius 6 centimeters if the angle of the sector is 60 degrees. So we know the formula to find the area of a sector is theta by 360 times pi r squared. And they've given the radius and they've given the value of theta, which is 60 degrees. So we're going to substitute the value here. So 60 divided by 360 times pi, which is 22 by 7, times r squared, which is 6 times 6. So 0 and 0 will get cancelled. This will become 1 by 6, and this 6 and this 6 will get cancelled. So we will be left with 22 by 7 times 6. So 22 times 6 is equal to 132 over 7 centimeters squared, which is the area of the sector. In the second question, they're asking us to find the area of a quadrant whose circumference, meaning its perimeter, which is 2 pi r, is equal to 22 centimeters. And since they're saying it's a quadrant of a circle, that means the theta value will be 90 degrees. And they're asking us to find the area of the sector. So we're going to use the formula theta over 360 times pi r squared. So theta is 90 degrees over 360 times, and we need to find the value of r before we can substitute it here. So we can write 2 times 22 by 7 times r is equal to 22. So 7 will be brought over to here, so we'll have 22 times 2 times r is equal to 22 times 7, and r is equal to 22 times 7 by 2 times 22, where 22 and 22 will get cancelled. So 7 by 2 is equal to the radius. So now that we know the radius, we can find the area of the sector. So it's theta over 360 times pi, which is 22 by 7, times r squared, which is 7 by 2 times 7 by 2. So 2 and 22 will get cancelled, 7 and 7 will get cancelled, 0 and 0, and 9 over 36 is equal to 1 by 4. So now we will have 77 by 8 centimeters, which is equal to the area of the sector. In the third question, they've given that the length of the minute hand is 14 centimeters, which implies that the radius is 14 centimeters. Well, they're asking us to find the area swept by the minute hand in 5 minutes. So we need to find the area in 5 minutes. So first, we need to find out how much the angle covered when the minute hand passes over 5 minutes. So in order to, first we need to find the area swept by the minute hand in 1 minute. And in order to do that, we will divide 360, which is the total angle or rotation in a clock, divided by 60, which is the amount of minute divisions in a clock, which will give us the area swept by the minute hand in 1 minute. So 36 divided by 6 is equal to 6. So 6 degrees in 1 minute. So they're asking us to find it for 5 minutes. So the area, the angle in 5 minutes would be 6 times 5, which is equal to 30 degrees. So this is equal to the value of theta. Now that we know the value of theta and the value of r, we will be able to find the degree. We'll be able to find the area of the sector. So the area of the sector would be 30 divided by 360 times pi, which is 22 by 7, times r squared, which is 14 times 14. So 0 and 0 will get cancelled. 3 and 36 would be 1 over 12. 7 and 14 will get cancelled. 2 and 12 will get cancelled. We'll have 6. And this would be 11. This would be 3. So we will be left with 14 times 11 over 3. And 14 times 11 is equal to 154 over 3 centimeters squared, which is the area of the sector in 5 minutes. In the fourth question, they're telling us that a chord of a circle of radius 10 centimeters subtends a right angle at the center. We need to find the area of the corresponding. First, we need to find the minor segment. So first they're asking us to find the minor segment. And then secondly, they're asking us to find the major sector. And they're asking us to take the value of pi as 3.4. So in order to find the minor segment, we know that the radius is equal to 10 centimeters. The value of theta is equal to 90 degrees. So we know that the area of the segment is equal to the area of the sector minus area of the triangle AOB. So first we need to find the area of the sector, and then we need to find the area of the triangle. So first, in order to find the area of the sector, we're going to use the formula theta over 360 times pi r squared. So the value of theta is equal to 90 degrees, so 90 over 360 times pi, which is 3.14, times the radius squared, which is 100. So 0 and 0 will get cancelled. 1 over 4 times 100 times 3.14 is equal to 314. So we will get 314 over 4, which is equal to the area of the sector. And 314 divided by 4 is equal to 78.5. Now we need to find the area of the triangle. So we know that the area of the triangle is half into base into height. And we know the base is 10, and the height is also 10. So the area of triangle AOB would be half into 10 into 10. So 10 times 10 is equal to 100. 100 divided by 2 is equal to 50. So the area of this segment is equal to 78.5 minus 50, which is equal to the area of the segment. So the area of the segment is equal to 28.5 centimeters squared. So next they're asking us to find, so this would be the answer to the first part of the problem. Next they're asking us to find the major sector. So we know that the value of theta is equal to 90 degrees, the value of r is equal to 10 centimeters. And we know that the area of the major sector is the area of the whole circle, which is pi r squared, minus the area of the minor sector. And we found out that the value of the minor sector is equal to 314 by 4, which is equal to 78.5. So pi r squared would be 3.14 times r squared, which is 100, minus 78.5. So 3.14 times 100 is equal to 314. So 314 minus 78.5 is equal to the area of the major sector. So 314 minus 78.5 is equal to 235.5 centimeters squared, which is equal to the area of the major sector. In the fifth question, they've given that in a circle of radius 21 centimeters, an arc subtends an angle of 60 degrees at the center. We need to find the length of the arc. So we know that the formula for finding the length of the arc is theta over 360 times 2 pi r. The value of theta is equal to 60 degrees, so 60 divided by 360 times 2 times pi, which is 22 over 7, times r, which is 21. 7 and 21 will get cancelled, so 3. 0 and 0 will get 1 over 6. 3 and 6 will get cancelled. 2 and 2 will get cancelled. So 22 centimeters would be the length of the arc. Next, they're asking us to find the area of the sector formed by the arc. So they're asking us to find the area of the sector. We know that the area of the sector is equal to theta over 360 times 2 pi r squared, times pi r squared. So the value of theta is equal to 60 degrees over 360 times pi is 22 over 7 times r squared, which is 21 times 21. 7 and 21 will get cancelled. 0 and 0 will get cancelled. 6 and 36 we will get 1 over 6. 3 and 6 will get cancelled. 2 and 22 will get cancelled. So we will be left with 21 times 11. And 21 times 11 is equal to 231 centimeters squared, which is the area of the sector. Third, they're asking us to find the area of the segment formed by the corresponding chord. We know that the area of the segment is equal to the area of the sector minus the area of the triangle. Minus the area of the triangle, we're going to name it AOB. So we already know the value of the sector, the area of the sector. We just need to find the area of the triangle. So the area of the triangle, we know that they've given that the angle at the top is 60 degrees and both sides are 21. And we need to find the base and the height in order to find the area of the triangle. So we're going to draw a perpendicular line. So this part will equal 90 degrees and this half of the angle would equal 30 degrees. So we need to find the value of the base and the height of the triangle. So we're going to use the trigonometric identities in order to find the opposite side and the height of the triangle. So first let's find sine 30 degrees. Sine 30 degrees will give us the opposite over hypotenuse. So the opposite would be this part right here. So opposite over hypotenuse, which is 21, which is equal to 1 over 2. So 2 times opposite over 21 is equal to 1, and 2 times the opposite is equal to 21, and the opposite side is equal to 21 over 2. So this part is equal to 21 over 2. Well, the whole base would be 21 over 2 plus 21 over 2. So when we add both of these values, we will get 42 over 2, which is equal to 21. So the base of the triangle is equal to 21. Next, we need to find the value of cos 30 degrees. So cos 30 degrees would be adjacent over hypotenuse. So we don't know the value of the adjacent, but the adjacent is the height of the triangle, and the hypotenuse is 21. And we know the value of cos 30 degrees is equal to root 3 over 2. So 2 times the adjacent is equal to 21 times root 3. A is equal to 21 by 2 times root 3. So now that we know these values, we can substitute them in the area of the triangle formula, half into base, which is 21 over times 21 root 3 divided by 2. So the area of the triangle would be 441 root 3 divided by 4. So now we need to find the area of the segment. So the area of the segment is equal to the area of the sector, which we found is 231 minus 441 root 3 divided by 4, which is equal to the area of the segment. In the sixth question, they've given that a chord of a circle of radius 15 centimeters subtends an angle of 60 degrees at the center. We need to find the areas of the corresponding minor and major segments of the circle. We need to use pi as 3.14 and the value of root 3 as 1.73. So we know that the area of the segment is equal to the area of the sector minus the area of the triangle. So first we need to find the area of the sector. So we know the area of the sector is theta over 360 times pi r squared, which is 3.14 times 15 times 15. So when we simplify this, we will get 0 and 0 will get cancelled, 6, 1 over 6. And moreover, when we simplify this, we will get 117.75 centimeters squared. Next, we need to find the area of the triangle. So the area of the triangle, we're going to write it separately. So we're going to draw a perpendicular line from the top so that this would be the angle bisector. So both of these angles will equal 30 degrees each. And we know that these two values will be 15. We need to find the height of the triangle and the base. So first, let's find sine 30 degrees. So sine 30 degrees is equal to opposite over hypotenuse, which is 15, which is equal to 1 over 2. 2 times the opposite is equal to 15. The opposite value is equal to 15 divided by 2. The whole base would equal 15 by 2 plus 15 by 2, which is equal to 30 divided by 2, which is equal to 15. So the whole base of the triangle is equal to 15. Now we need to find cos 30, which will give us the height of the triangle. Adjacent over hypotenuse, which is 15, which is equal to root 3 divided by 2. 2 times adjacent is equal to 15 root 3. Height is equal to 15 root 3 divided by 2. So the area of the triangle would be half into base, which is 15 times 15 root 3 divided by 2. So this will give us 225 root 3 divided by 4. And we know that they're asking us to use the value of root 3 as 1.73, so we're going to multiply 225 times 1.73, which will give us 97.3125. So the area of the segment would be 117.75 minus 97.3125, which is equal to 20.4375 centimeters squared, which is equal to the area of the segment. Next, they're asking us to find the area of the major segment. We know that the area of the major segment is the area of the whole circle minus the area of the minor segment. So it's pi r squared minus 20.4375. So 3.14 times 15 squared minus 20.4375. So we will get 706.5 minus 20.4375, which is equal to 686.0625 centimeters squared, which is equal to the area of the major segment. The seventh question they've given that a chord of a circle of radius 12 centimeters subtends an angle of 120 degrees at the center. We need to find the area of the corresponding segment of the circle. And we need to use the value of pi as 3.14, the value of root 3 as 1.73. So first, we need to find the area of the segment. In order to find the area of the segment, we know that it is area of the sector minus area of the triangle. So first, let's find the area of the sector. We know that it is theta over 360, which is 120 over 360, times pi, which is 3.14, times r squared, which is 12 times 12. So 0 and 0 will get cancelled. So 12 over 36, which will give us 1 over 3, times 3.14 times 12 times 12. So 3 and 12 will get cancelled, so it is 3.14 times 4 times 12, which is equal to 150.72. Next, we need to find the area of the triangle. We know the area of the triangle is half into base into height, so we're going to draw a perpendicular, which is the angle bisector of the angle 120 degrees. So both of these angles will be split, so 60 degrees plus 60 degrees. We know the values of both the sides of the triangle are 12 degrees. So we need to find sine 60 degrees, which will give us root 3 by 2, which is equal to opposite over hypotenuse, which is 12. So 12 root 3 over 12, which is equal to the value of the opposite side. So this will give us 6 root 3, but the base, the whole thing, would equal 12 root 3, because it's 6 root 3 plus 6 root 3, which will give us 12 root 3, which is the base of the triangle. Next, we need to find the value of cos 60 degrees. The value of cos 60 degrees is equal to 1 over 2, which is equal to adjacent over hypotenuse, which is 12. So 12 over 2 is equal to the value of the adjacent. So the value of the height of the triangle is equal to 6 centimeters. Now we need to find the area of the triangle, which is half into base, which is 12 root 3 times the height. So 12 and 12 get cancelled. So we'll be left with 6 times 6 root 3, which will give us 36 root 3. And they're telling us to take the value of root 3 as 1.73. So when we multiply 36 times 1.73, we will get 62.28 centimeters squared. So the area of the segment would be 150.72 minus 62.28, which is equal to 88.44 centimeters squared. In the 8th question, they've given that a horse is tied to a peg at one corner of a square-shaped grass field of side 15 meters by means of a 5-meter long rope. They're asked us to find the area of the part of the field which the horse can graze. And they're asking us to use the value of pi as 2.14. So we know that the area of the sector, here the value of theta is equal to 90 degrees, so the area of the sector is 90 over 360 times pi, which is 3.14, times r squared, which is 25. So 0 and 0 get cancelled. 1 over 4 times 3.14 times 25. So we will get 19.625, which is equal to the area which the horse can graze. The second part of the question, they're asking us to find the increase in the grazing area if the rope is 10 meters instead of 5 meters. So that means here the new radius would be 10 meters. So we need to find the area grazed if the rope was 10 meters, subtracted by the area grazed if the rope was 5 meters to get our answer to the question. So the value of theta will remain the same, so 90 over 360 times 3.14 times 10 squared, which is 100. So 0 and 0 will get cancelled. 9 over 36 is equal to 1 over 4. So we will get 314 divided by 4, which is equal to 78.5. So the increase in the grazing area would be 78.5 minus 19.625, which is equal to 58.875 meters squared. In the 9th question, they've given that a brooch is made with silver wire in the form of a circle with diameter 35 millimeters. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors, as shown in the figure. They're asking us to find the total length of the silver wire required. We know that the total wire used is equal to length of the wire plus the wire used in the 5 diameters. So, first we need to find the length of the wire in the circle, which means, let's just write that down. Total wire used is equal to the length of the wire in the circle plus the wire used in the 5 diameters. So the radius of the brooch would be 35 divided by 2, because the diameter is equal to 35. So this will equal the radius. So the first we need to find the length of the wire used in the circle, which is none other than the perimeter of the circle. So the perimeter of the circle would be 2 times pi times r. So 2 times 22 divided by 7 times r. So 2 and 2 will get cancelled, 7 and 35. So 22 times 5, which is equal to 110 millimeters. Plus the wire used in 5 diameters, which is 35 times 5, which is equal to 175. So when we add both of these values, we will get the total amount of wire used. So 175 plus 110 will equal 285 millimeters, which is equal to the total wire used. In the second part of the question, they ask us to find the area of each sector of the brooch. So the area of the angle measurement for one sector of the brooch would be 360 divided by 10. So this would be the value of theta. So the area of each sector of the brooch would be 36 over 360 times 22 by 7 times 35 by 2 times 35 by 2. So 36 and 360 will get cancelled, so 1 over 10. 2 and 22 will get cancelled. 7 5s are 35. So we will be left with 11 times 5 times 35 divided by 10 times 2. So when we simplify this, we will get 385 divided by 4 millimeters squared. In the 10th question, they've given that an umbrella has 8 ribs which are equally spaced. Assuming umbrella to be a flat circle with radius 45 centimeters, we need to find the area between the 2 consecutive ribs of the umbrella. So they've given us the value of the radius. We need to find the area of the sector, but they haven't given us the value of theta. So we need to find the value of theta. And so they've given that it is divided into 8 ribs, meaning the circle is divided into 8 sections. We can find the value of theta is simply 360 divided by 8. So 360 divided by 8 will give us 45 degrees. So each sector's value of the angle between each sector would be 45 degrees. So 45 divided by 360 times pi, which is 22 by 7, times r squared, which is 45 times 45. So when we further simplify this, we will get 1 over 8 by 22 times 7 times 45 times 45. So this and this will get cancelled to 4 and 11. So we will get 11 times 45 times 45 is equal to 225. So 2025 divided by 4 times 7, which is equal to 22,275 divided by 28 centimeters squared, which is the area between the 2 consecutive ribs. In the 11th question, they've given that a car has 2 wipers, which do not overlap. Each wiper has a blade of length 25 centimeters sweeping through an angle of 115 degrees. We need to find the total area cleaned by each sweep of the blade. So they've given us the value of the radius, which is 25 centimeters. So the area of the total area cleaned by 2 blades would be 2 times the area of the sector with angle 115 degrees. So 2 times 115 degrees divided by 360 times pi, which is 22 by 7, times r squared, which is 25 times 25. So when we simplify this, we will get 158125 divided by 126. So this would be the area cleaned by both of the wipers together. So in the 12th question, they've given that to warn ships for underwater rocks, A lighthouse spreads a red colored light over a sector of angle 80 degrees to a distance of 16.5 kilometers. We need to find the area of the sea over which the ships are warned. We need to use pi as 3.14. So we just need to use the sector formula, which is theta over 360 times pi r squared. So it is 80 over 360 times 22 by 7 times 16.5 times 16.5. So this will cancel out to 2 over 9 times 22 by 7 times 16.5 times 16.5. So when we simplify this, we will get 189.97 kilometers squared, which is the area warned by the lighthouse. So in the 13th question, they've given that a round table cover has 6 equal designs as shown in the figure. If the radius of the cover is 28 centimeters, find the cost of making the designs at a rate of 0.35 per centimeter squared. So they've given that the table cover has 6 equal designs. So the area of each of the sectors would be 360 divided by 6, which will give us 60 degrees. So that is why each of these sectors have an angle of 60 degrees. So now they're asking us to find the cost of the designs. So meaning we need to find the area of this segment. So we know that the area of this segment is the area of the sector minus the area of the triangle. So we need to find the area of the segment. So first we need to find the area of the sector, which is 60 over 360 times pi 22 over 7 times 28 times 28. So this and this will get cancelled, we'll get 4, 1 over 6. So when we simplify this, we will get 410.67 centimeter squared, which is the area of the sector. Now we need to find the area of the triangle. So this would be the angle by sector. So both of these angles will equal 30 degrees. So we need to find sine 30 degrees, which is equal to opposite over hypotenuse, which is opposite over hypotenuse, which is 28 degrees, 28 centimeters, which is equal to 1 over 2. So the value of the opposite would be 14, but the whole base would equal 28 centimeters. Next, we need to find cos 30 to give us the height of the triangle. So cos 30 degrees is equal to adjacent over hypotenuse, which is equal to root 3 over 2. So 2 times adjacent is equal to 28 root 3. A is equal to 28 root 3 divided by 2, which will give us 14 root 3. So the area of the triangle would be half into base, 28 times 14 root 3, which is the height. This and this will get cancelled, so 14 times 14 root 3, which will give us 196 root 3. And instead of root 3, we're going to write 1.7, which will give us 333.2 centimeters squared. Therefore, the area of the segment would be area of the sector minus the area of the triangle. So 410.67 minus 333.2, which will give us 77.47. So the area of the design would be 77.47 times 6, because there are 6 equal designs. So 77.47 times 6. 77.47 times 6 is equal to 464.82 centimeters squared. They're asking us to find the cost of the design. So the cost of the design would be 464.82 times 0.35, which will give us 162.68 rupees, which is the cost for making all 6 equal designs. In the 14th question, they're asking us to take the correct answer in the following. Area of a sector of angle P in degrees of a circle with radius r is. So the value of theta is equal to p over 360 degrees times pi r squared. So when we rearrange this, we will get, so in the given options, they've given pi over 180 times 2 pi r, which is wrong. Pi over 180 times pi r squared is also wrong. P over 360 times 2 pi r is also incorrect. The last option is p over 720 times 2 pi r squared. So if we multiply both of these terms with 2, we will get, so when we multiply both the numerator and the denominator by 2, we will get p over 720 times 2 pi r squared. So that means that the option 4 would be correct. Option D, which is p over 720 times 2 pi r squared, would be the correct option.